Hey, this is Peter and welcome to another Take a Break with Valley CAD. So in this video, I have another design challenge for you. And this was one that I saw someone post up on a Facebook user group. It's a SOLIDWORKS user group. And they just said, hey, what is this thing called and how do I model this thing? And that thing that I'm talking about is actually this thing right here. But in today's video, what we're gonna work through is I'm gonna set up a drawing that I made. And by the way, if you wanna see that drawing as a PDF, if you look down below in the comments, I have a link there. Click on that and I'll give you the PDF version of this drawing. So that way you could try to do it on your own setup as well. So without holding you guys up much longer, go get your favorite cup of coffee or tea and I'll see you in SOLIDWORKS in just a click. Hey there, welcome to SOLIDWORKS. So you'll see I have the 2D drawing here. And by the way, this 2D drawing is what you have as a PDF file if you clicked on the link below. All right, so before we get modeling inside of our new design here, it's a good practice to figure out what planes do I want to sketch on, where do I want my origin to be located, and also what are my basic shapes to make this thing. Okay, so as we get modeling into this, you'll also notice that in my section EE, section that there's kind of some weird dimensioning schemes here and doesn't really tell me the value of how far away this edge is from that edge. And I did that on purpose because one, it matches the picture that we used, and also it helps us to figure out how we might model this differently using features to figure out our dimensions there. All right, so without holding us up much longer, because this might be a little bit of a longer video, let's start up a brand new part file. So in here, I'm gonna say parts, and I'm gonna just do our standard one. This is one that we use at Valley CAD here. And so before we get rocking, I'm gonna have the picture up above me right now. I want us to note that we are modeling in millimeters, and the template that I use here at Valley CAD is in inches. So if you need to switch that into millimeter form like I need to, you'll actually need to come down and kind of point right here where it says IPS, right? If you click on that, you'll see MMGS. I know my head is in the way, but click on MMGS. It's the second one from the bottom there. That's millimeter, gram, seconds. All right, so now I'm in the right units of measure here. Now what we need to do is start modeling our part here. So I'm gonna switch into a tile vertically session here. So that way I can see my new part file and I can see my existing drawing file here. Okay, so as I was saying, we want to look at the basic shapes, like how we have kind of a circular shape here. We also kind of have like a triangular shape there. So those are really basic shapes, and that's what I would recommend to look at first. Now, the next step is what plane, and also where's the origin located? So looking at this is actually my front view. So I'm gonna create this off of my front plane. And it looks like how my dimensioning scheme is here. Looks like a lot of things are centered about the center of my circle there. So I'm gonna set that up as where my origin's located. So with my front plane selected, we're gonna go from there. I'm gonna push S for shortcut key and activate Boss Base Extrude. From here, if I use a mouse gesture to simply go into circle mode, that's sketching a circle, I could simply click like that, and that dropped in a circle for me. Now if I mouse gesture again, I go straight up, that will activate dimension mode. Then from there, I need to specify what my size is. So looking at my print here, I see that we have a 56 millimeter diameter callout. So I'm gonna change that to 56 and say okay to that. Perfect. So now as we say okay to that, what I need to do next is come in and figure out how tall is it gonna be extruding up. And so I have a 50 millimeter dimension there. So because I selected Boss Base Extrude first, watch what happens when I get out of my sketch. So I'm gonna click on my confirmation corner. SOLIDWORKS will automatically switch to Boss Base Extrude for me right out of that sketch. All right, so from here I need to set that up as 50 millimeters like so. Then from there, simply click the green check mark. Done, first feature made. Now I'm not gonna worry about the hole yet because SOLIDWORKS is a feature-based modeling software. So I'm gonna use features to make up my geometry. I'm not gonna come in with complicated sketches. I like to think of the acronym KYSS. That stands for Keep Your Sketches Simple. So we're gonna keep that same philosophy as we are modeling this part here. All right, so now coming in, next thing that we're gonna do is create our little triangle shape. So once again, I'm going to be on my front plane. I come up to features, boss base extrude, or use the S key for shortcut to create my geometry as well. So from here, I'm going to simply draw a line that's going to come across horizontally and then make a kind of like a triangular shape there. Awesome. Now I do not want this horizontal line connected to my origin, because as we kind of see in the print, see how this edge here is coming across above my center mark. So that's why I want to make sure I don't do that here as well. Now I normally don't sketch fillets. Normally I don't. I use the applied feature fillet command because like I was saying earlier, SOLIDWORKS is a feature-based modeling software, so I'm going to use features to make my geometry. In this scenario though, it is a better practice to come in with our sketch fillet because of how our dimensioning scheme is made up here. And also it'll help me figure out where I can locate my counterbore holes as well. So coming in here, I'm going to activate the sketch fillet command. And so with this, I see that we have a 15 millimeter radius and we need 3 of them, which is right there. So I'm going to change this to 15. And then from that 15, come through and click on my 3 corners and simply right click and then right click again, or I could click on the green check mark twice. Perfect. So now we have this. Notice how I can move my geometry around. What I'm going to do next is create a center line. I'm going to come from the midpoint of that horizontal line down to the center mark of that arc. And then from there, select the center line, hold down Control, select on the origin, and say be coincident like so. But you'll notice that I'm still able to kind of move this thing around all kind of weird, right? So what I want to do is simply click on that center line and say be vertical. Now what I did is I created symmetry about my part going along that vertical axis. Awesome. So now what we're going to do is come in and start adding some more dimensions. So I am seeing now we have a 40 millimeter dimension that's coming from the center of our circle there down to this bottom arc. And we have from hole to hole, or from center of arc to center of arc, is 80. So simply coming in here, smart dimension from here to here, and drop that as 80 millimeters. And then from here to here is going to be my 40. Now you will notice in my drawing here that I have a 15 millimeter dimension, but it has parentheses around it. I know in the print or the picture that I had, it did not have that, but what the bracket stands for is it says reference. Now, why did I put a reference dimension there? Well, this is specking off for our radius callout, which I'm already calling out right here. And so when I'm seeing this, I am personally not going to come in and create a smart dimension, go from origin to that line and say be 15. It will fully define it, but I'm adding rules to this that really aren't needed. Instead, what I would rather do is simply come in here and say that point to this point are horizontal. That will fully define it as well. And this one driving dimension will control all that. Now, if your design intent says, hey, I need this edge to this point to always be 15 millimeters away, then yeah, I would change it, because if I ever change this radius size, let's say to 10, notice how it just made that line get closer to the origin. It went smaller by 5 millimeters. So it really depends on your design intent. I'm going after the route where this is always going to be controlled by the radius size though. All right, so now we have that. We're going to come up here and we can say features, say boss base extrude, or we can say okay to this because this is how I started that feature. All right, so from here, we're going to say that we need to extrude up 15 millimeters. And my call out for that, I know my head is currently covering it, but it is 15 millimeters. And after I complete this step, I will show that to you. As you see right here, it says 15 millimeters right there. Okay, so now we got, our basic shapes made up. Not too bad, right? So now what we need to do is come in and create our extrusion for this little tab that's sticking up, okay? So as I'm looking at my front view, I have a 50 millimeter dimension that's coming off from my origin. I'm using my origin to help me model this. And it looks like the width of my tab is 20 millimeters and it's offset from the back edge by 15 millimeters. Now 15 millimeters is the same as that 15 millimeters. I'm going to show you another route here. Instead of dimensioning that, I'm going to use relations instead. So using my right plane, I'm going to say another boss base extrude on that. And I'm going to simply come in, draw a line that comes up, come over this way, and then push the letter A as an apple. What SOLIDWORKS will do is it'll actually switch into an arc mode for me. Very cool trick. Now I'm going to be intentional about this. I want to come in and snap it, and SOLIDWORKS will snap to that kind of horizontal dotted line there. It does not add a relation, but what SOLIDWORKS is saying is, hey, if you come off this way and click, I'll add a tangent relation there for you. And if you come straight down, I will now add another tangent and another vertical relation for you. Pretty cool. Then from there, I'm gonna simply close it. Okay. So now what we need to do is come in with some smart dimensions and relations. So we know that from here to my origin, and this is why I was intentional about where I placed my origin, is at 50 millimeters. And I'll show that in the drawing here to reference that. So 50 millimeters from the origin up to the center of that arc there. Then as we look at this view over here, we have that 20 millimeter dimension, right? So we're gonna smart dimension from here to here, inspect that out at 20. Now, the next thing is at 15 millimeters. Now, if my design intent always said that this edge or this future edge and this edge always need to be in line with each other, I'm just gonna add a relation, such as if I click on here and click on here and say be collinear, that will make it so it's fully defined. But this is still able to move. So the other thing you could have done was simply click on this point and drag it down to that point there. And now we'll add a coincident, which would cause this line to stay in line here, and also made it to where this line would stop at that point too. So use your gesture on how you want that to be fully defined. From there, what we need to do is extrude it out. Now, as we look at my detail view here, it says that we got a 20 millimeter cut in the middle. So I know I need at least 20 millimeter distance there. And then it has an 8 going one way, and I know it's not dimension, but more likely it's gonna be 8 going the other way as well. So I need to come in and create my values for that. Now keep in mind that 8 millimeter dimension is coming into that point, which is in line with this edge here. Okay, so from here, we're gonna simply say boss base extrude. And instead of doing a blind, I'm gonna do a mid plane. And from here, what I'm gonna do is set it up to where we're gonna do some calculations, but I'm gonna let SOLIDWORKS do it for me. So if I come in here and I type in 20, because I know I need that, plus 8, that's for one leg, and then push plus 8 again for the other side, which is 20 plus 16, we now get 36 millimeters. I'm gonna make sure my merge results is checked at this time as well. All right, now we got some more of our basic shapes made up. Now let's come in and start cutting out our geometry. So I'm gonna come in and we could simply click on this face here and we'll simply say extruded cut. I'm gonna do a simple rectangle. I'm gonna do a corner to corner rectangle. From here, what I'm gonna do next is come in and make it to where this line and this arc are tangent. Now, as we look at the print here, you can see that SOLIDWORKS has that, or my model has it that way, where it's coming in and it's tangent at that arc. So that tangent relation will achieve that. Now I'm gonna come in with a center line and I'm gonna click on the midpoint of that horizontal line and come down to my origin and say be vertical. Now with this is gonna be symmetrical about that vertical plane again. Awesome. So now from here, we need to put in our dimension of 20 millimeters. Done. All right, cool. So now with that set up, we say cool, and we will cut that all the way through, and I'll say through all on there. And I can say through all both. It doesn't really matter since I'm on this top surface and I just wanted to cut through that one tab. We're good. Okay, so now that we have that set up, the next thing that we're gonna work on is our little chamfer, or our little bevel piece that's coming off. So I'm gonna come back into our detailed view here, and I'm gonna use these two dimensions at 45-degree angle and at 16 millimeter diameter to make this part. So coming in here, I need to create a plane that's gonna be bisecting this tab. So what I can easily do is come up to my features, and I'm gonna come in and select reference geometry and select plane. If I click on this top surface and this bottom one here, SOLIDWORKS will come in and will make a bisecting plane for me. Cool. Simply right click or click the green check mark and we're done. Now what we're gonna do next is come in and create a sketch for a revolved boss base. So selecting plane number 1, I can say let's make a new sketch on that. And so now what we're gonna do is create that profile. Now, as I mentioned, we're gonna create a revolved boss base with this. With a revolved boss base, you wanna make an asymmetric sketch here. So I'm gonna come in at that kind of 45-degree angle. I'm gonna come down however far, come back over, and then close it. Now, where do we place our center of rotation for this thing? Well, sometimes it's hard to tell where that is. Like in this scenario, it's actually that tangent edge that's showing up there. But sometimes you might have a tangent edge that's technically not right on top of center for you. So what I would recommend to do is come up to your heads up toolbar, click on that drop down, and this little dotted line that's kind of grayed out. This is called your temporary axis. So whenever you make a circular object inside of SOLIDWORKS, an arc or a circle, SOLIDWORKS will come in with what's called a temporary axis. I can use that to help me make my geometry. So I want to come in and create a center line as well. That's going to just simply come off yay far. Don't really care about how far over it is. I personally like to fully define my sketches, so I'm going to simply do that here. Then from there, what I can do is simply click on that center line, hold down Control, select that temporary axis, and say, hey, be collinear. And then that's done. So now what we need to do is come in and fully define this thing. So I'm going to click on that line, click on that angled line there, and say be 45 degrees. Cool. Now here's a reason why I added a center line here. And I'm going to turn off that temporary axis because I don't need to see it anymore. But I do need to see that center line there. Okay, so with that center line, if I come in and click on this top point where that bevel comes in and connects with that beginning of our circular shape, and then come in and select that center line. If I have those two selected, look what happens when I go below the center line compared to being above it. If I go below it, SOLIDWORKS will automatically switch into a diameter mode for me. With that, put in my 16 millimeter diameter, and I'm fully defined. Now I'll come up to features and we'll say revolved boss base, and it revolves nicely for me. In this scenario, I'm going to uncheck merge results and then say okay to that. So with this geometry, what I needed to do is I need this little bevel piece show up on the other side. Now I purposely unchecked the merge results. So you see here I have two separate bodies in my bodies count. I have this one and then that revolve. The reason is because sometimes, like when I modeled this earlier, when I mirrored it over and I used the features parameter, I had a geometry condition error that popped up. So the easy way to fix that is simply just don't merge the result. Then when you come in and you do a mirror command, I could say, hey, let's mirror about my right plane. Instead of using features to mirror, I'm going to say use bodies to mirror. Then simply say okay to that from there. That will take care of that issue with like geometry condition and so forth, or geometric conditioning. So that's a nice little trick that you could work around in case you have such error as that. Now you will notice that I have three separate bodies. I need to make this all one body in the end. So I'm going to use a feature called the combine tool, the combine feature. I love this feature. I use it all the time. So activating that, I'm going to simply come in here and do a window. SOLIDWORKS is going to find all three bodies and it's going to add them all into one for me. Done. And you can see that in my solid bodies folder here. So once again, I mirrored that without the merge results for the purpose of mirroring it. Okay, so now what we need to do is come in and add some of our cuts and fillets on here. So looking at our cutout here, so I need a cutout that's going to go in our center here. I'm going to do a simple extruded cut like so and just do a simple diameter and call that out like so, smart dimension it, and the diameter on this is at 30 millimeters there. So 30 millimeters, cool. And then from here, we'll say features, cut extrude, and we'll say cut through all on this one. And we're done with that. Then from there, we need to come in with another cut that's on the side here. I'm going to use Hole Wizard this time for that. And with this, I'm going to do an ANSI size, and we're going to do standard drill, ANSI metric. Diameter is going to be 12. As we can see, it's a little cut off, but it's a 12 millimeter diameter on that. So position this little hole. I'm going to hover over the circumference of a circle. That will activate the center mark for me. And then have that come through and cut. And by the way, that's where that 12 through all is coming from in your print. Then to finish off this model, we're going to simply come in and we're going to activate Hole Wizard again. And what we want to do is do a counter bore size. Now, as you see here in the print, let me get out of Hole Wizard so we could zoom in on it. In the print, it says that, hey, we need to do a 10 millimeter hole through all. We need a counter bore, and the diameter of that's at 16, and the depth of that is 5. Okay, So with that, that's why I'm going to use Hole Wizard. And with that, counter bore. Now, if I came in and I said, let's do an M10 size hole, and I said, all right, that looks good, and I position it, I don't know if that's actually going to be the right size. Actually, it's not. Because if I hover over and I come through and I click on these, notice how big my outside diameter is, and notice how close that is to this edge. Then look at my print. Notice how far away they are for this one. So that is not going to be the right size. So if I come in here and say show custom sizing, you'll see here that SOLIDWORKS, when I use an M10 size hole, it's actually coming in and creating a 11mm cut and 21 counterbore size and so forth. I don't want that. So if I come in here and it says do an M8, oh, still not the right size. But because I have show custom sizing, I can actually come in here, fill in these values on my own. And that's just a really convenient tool that you can actually utilize while you're working through Hole Wizard. And simply right click and you have it done there. Sweet. Then the last thing that we got to do is come in and add some fillets. Now I recommend when you're doing fillets that you always want to start with your biggest radius first. I'm using Fillet Expert for this scenario, not manual. The reason is because I can just stay in this one command and add multiple fillets at the same time. So we have an 8mm radius. That 8mm radius is on this bottom edge here and this bottom edge here, and simply right click. Then I have a 5mm radius. Those 5mm is for the tab here, the transition. Simply right click. Notice I'm still in my command of fillet. Then my last one is at 4mm, and we'll click here, and then click here, and then also this top edge, and then simply right click again. And then simply get out of that command. So that actually came through and I completed our entire model. Woo! As I said, this is a little bit of a longer video, but hopefully you got something pretty nifty out of that, especially that aspect of don't merge your results and mirroring bodies about each other. That is super powerful actually. Awesome. Well, I hope you're enjoying these videos. If you are, please click that thumbs up button. Also click subscribe so you get notified for future videos that we are posting here on our Valley CAD YouTube channel. Have a great rest of the day and make sure you learn something new. See ya.